this problem, we're going to first use our calculator to see if we can figure out what the limit of this might be, and then we're going to prove it algebraically. So let's go to y equals, and let's enter in our function. I'm going to use parentheses sine x for my numerator, divided by, in parentheses for my denominator, 2x squared minus x, close the parentheses, and I'm going to go zoom 6 and see what the graph looks like. Oh, looks like a straight line. Oh, and then it kind of goes down, I have a couple of branches there. So I'm looking for this as x approaches 0, and I think I'd like to zoom in on it. And the way I like to zoom in on things is to change the window. So instead of having the 10 by 10 window, which is the zoom 6, I'm going to go to window, and generally speaking, I'll start it, unless I know exactly where I'm going, if I go from -4 to 4 on the x, and go from -4 to 4 on the y, and then I press graph. I don't press zoom 6 again, that'll take me back to the 10 by 10, and I can see, okay, it's looking a little bit more clear. So I'm guessing that as x is approaching 0, I'm thinking that my limit, I'll put an equal sign with a question mark because I'm not positive, is -1. That's what it's looking at. I wish I could draw on this, but it would be right there. You can kind of see me moving the pencil maybe a little bit. Oh, a little pen pointing. How about that? Okay. So let's take a look at it on the table. So I'm going to go second table set. And I want to start it, since I'm looking for it as x approaches 0, I want my table to start at 0. I like the delta table, the change in the table increments. I like it to start about 0.01. That's a good place to start. It's small enough. And so I'm going to go second table. And now I'm starting at 0, so I scroll up a little bit to see the ones below 0. And again, it's looking to me as if the answer is going to be -1. So from the calculator, that's what I think the answer is. Now, can I prove that algebraically? Well, I'm going to take my function, sine x divided by 2x squared minus x, and I'm going to mess around with it a little bit. I'm going to call it sine x divided by 2x times x minus 1. No, that's wrong. I can't factor out a 2. It's sine x divided by x times 2x minus 1. That looks a little bit better to me. So I'm going to mess with this algebraically a little bit. And I'm going to turn it into sine x divided by x times 1 over 2x minus 1. If I multiplied that straight across, I would get my sine x over x times 2x minus 1. So this is legit. And if you remember from class, this expression right here, we proved this. This is equal to 1. We can go back and do that another time, but you can look at it. This is something that you should just really commit to memory, because you are not going to be able to do calculus with trigonometric functions unless you know that sine x divided by x is equal to 1. Well, if I do that, I have 1 times 1 over 2x minus 1. Now you remember we're trying to find the limit as x approaches 0 of now 1 times 1 over 2x minus 1. And if we use our properties of limits, this is the same thing as the limit as x approaches 0 of 1 times the limit as x approaches 0 of 1 over 2x minus 1. Well, the limit as x approaches anything of a constant is the constant. So that's 1. And I have 1 times. Now, this right here is a rational function. It's a polynomial divided by a polynomial. I can use substitution. So this would be the limit of 1 over 2 times 0 minus 1. So I have 1 times 1 over 0 minus 1 equals 1 times 1 over negative 1, which is equal to negative 1. So we have proven algebraically what we had suspected from our calculator.